Good morning, Miriam. Get my dashboard pulled up on my phone. Okay. Edit. Good morning. No problem. We got it figured out. Nala, hush. What are you growling at? Good morning. We're still a few minutes early. I just wanted to go ahead and give people a chance to come say hello. Where's my progress thing? Yes, good. Okay, Katie, I do have you in here. Oh, and getting started on the assignments. Well done. I have golden doodles. There's one right here. No, come back. It's my big nugget. It's much not my big nugget. She's medium compared to the others. I have a cat, which is obviously smaller, and then I have a bigger dog who's over there. But he's behind your chair, so I can't show you. Teddy bear. Ooh, I have a song for this. Where is it?
Oh, baby, let me be your loving teddy bear. Put a chain around my neck and lead me anywhere. Oh, let me be, your teddy bear. I don't want to be your tiger.
Why'd I change my setup?
Tigers play too rough.
So I have difficulty with lighting. My evening class, the light was like right behind the camera and like the sun on me. So I was just like trying to hide from the sun. I was like getting lower and lower. It was kind of rough. And it was also a little awkward in some ways. I was like in the middle of the house. So I'm trying this, although my lighting is now very one-sided. You can see the sun over here. So I'm going to try to like face the large windows that I have over here. I don't know. I might end up, this table is octagon. So I may move over to the other side so I get better lighting.
I don't wanna be your tiger, 'cause tigers play too rough. I don't wanna be your lion, 'cause lions ain't the kind you love enough. I just wanna be your teddy bear.
Working from home is rough, she says.
your teddy bear.
I just wanna be your teddy bear. Good morning. Oh. I don't know what this is. I don't want this. No. You guys can stop. You did great. Fun fact, this is a song that I quote all the time and nobody ever knows what I'm talking about. Or it's a, cover of it. Okay, go ahead. I gotta fix it now. I said, go ahead and make a bid on that. So I said, hey, pretty lady, won't you give me a sign? I'll do anything to make mine on mine. I'll do your bidding and I'll be at your beck and call. Yeah, I've never seen anyone looking so fine. It's just one of a kind. I'm going once, going twice, sold. I am personally not playing Animal Crossing, although I do have some friends that have been trying to talk me into it. Ooh, English. I don't know. Is it fun? What do you think? Should I get it? I have a Switch about 50 feet that way. Cause I just shouted out above the crowd and I said, no, need more attention. Okay. I actually do sing some. I've been thinking about getting back involved. I sang in a chorus for like 3 or 4 years in grad school, undergrad. I've been thinking about doing it again. There's a chorus that sings music like this. This is barbershop music. It doesn't sound like what you might think. And there is a barbershop chorus in like the close west suburbs that's pretty good. I forget their name off the top of my head, but they rehearse on Tuesdays, and I've had class on Tuesdays some, so I haven't been able to go, but man, I'm gone, gone. I'm not actually a bass, it's just fun to sing. Gone. Okay, it is time to get started, and I will sing along if I have this playlist on, so I gotta pick something else. Let's do, that's probably distracting. I have a quote-unquote background music playlist, but I have a theory that it probably end up being really distracting. Let's find out. I'll probably end up turning... Actually, I'm just going to turn it off. This is not a good idea. Okay. Yes, we're having class today. It's time to get started. Oh, good. And my viewer count just shot up. It is, in fact, time. I want to be a little patient in terms of getting class started exactly on time, at least at first, as we're all fumbling around with technology. You can see my lighting's not right, so I'll probably have to end up shifting everything I have here 90 degrees to the side so I get the light from this angle. But this is super distracting. So my parents live in what was at least super rural. It's still pretty rural. In East Tennessee, and it is just absolutely gorgeous. So I look out, if I face this way, I'll be looking into the backyard. If my webcam can adjust. Out into the back garden with a big redbud tree in bloom, and yeah, it's just gorgeous. Mountains in the background. So how am I supposed to pay attention with that kind of view? It's just not going to happen, right? So... Oh, I messed up my webcam angle. Oh, it's so finicky. That'll do. Okay, so might as well get started. So I just wanted to start here. Start on the home page here to remind you that there are announcements that are being shared with you. I updated them on Monday. I didn't re-update them today because nothing's really changed. I did tweak one thing, actually, but I didn't bother making a new slide for it. Man, these servers have gotten slow. Okay. So, you may want to download it to make it easier to actually read everything, but I want to scroll this up. I want to scroll this down. Okay. So you've heard me talk a lot about the university climate study. I don't know about you, but I completely forgot about it for at least 2 weeks because this just doesn't seem important right now. So fortunately, our administration and the consultants have agreed, and they have given us an extra month to fill out the survey. So I'm putting it on the announcement slides just to kind of remind both of us, both you and I, both you and me. But I don't really want you to focus on it right now. If you got time, great, knock it out. Now, if you are seeing my lecture, which we have most of the classes is in Twitch right now, I have talked to a couple students who said they couldn't be here, which I have chastised them and encouraged them to be on time, but what can I really do? I guess I'll just have to be, just punish people for not coming to class. Tear. Oh well. So if you're here, you already know about Twitch. Don't forget about the thing on Discord. I am in Discord right now. A handful of you are as well. Great. Remember that if you want to ask a question in the Discord, all you have to do is unmute yourself if you're already in the call. However, if you don't have headphones in, I will hear you'll hear the stream, which means you'll hear your voice through the stream. The voice will hear you, and then it'll just loop and will echo. It'll be kind of a nightmare. So please have headphones or turn your volume down low if that's an option. Also, so you may have noticed a little bit ago, I pinged at everyone as a command. You can also ping specifically to me at Rob Cook, and I will get a notification. Yes, you put the space in there. If you forget the space, it'll kind of figure it out. So I did this earlier. You can see that Bart used it yesterday. At ROB. Wow, ooh, interesting. Is it a capital R? Interesting. Okay, so don't put a space, even though there's a space in the name. Huh. We learned something together. At ROB. I'm the only one. You can just push tab, and it will autocomplete for us. Okay, that's Discord. That's how you ping me, and you can access MindTap for free on D2L. There's a 14-day trial. I couldn't remember if I said this in class last time, so let me make sure I say it again. The publisher, Cengage, has given us unlimited 14-day trials, both in terms of concurrent unlimited, as many students as I want, but then we can repeat 14-day trials until the semester's over. So don't pay for it. It's free. You have your 14-day trial as long as you can keep renewing. And if we have any problems with the 14-day trials, let me know. I got a message from the Cengage representative to NEIU. We have a particular rep we work with. She reached out to me yesterday, just checking in, making sure everything's okay. So if worse comes to worse, I'll reach out to her and we'll figure out what's going on. But that's been promised that we'll be able to keep using those. Okay, so assignments coming up. There are things on MindTap. I'm a little frustrated right now because apparently I can't actually curate what goes in the assignments. Which means I can't take questions out or put questions in, which is really annoying, and kind of defeats the purpose to a degree. It doesn't let me customize it at all. So, like, for example, I couldn't take out the question in Chapter 5 about hypergeometric, which I think we started to talk about in class, but we didn't, really get into it. and it's just kind of a hot mess. And honestly, I was going to just skip it for this semester, but I can't take it out as best I can tell. So I think I'm going to have to reach out to Lindsay. But I found on the help documentation there was no indication that I can edit it. So I'll see what I can do for the future. But this part may end up changing. It may end up being all through D2L, which would be a big pain in the butt. I'm hoping that's not what happens, but I was misled by the edit buttons. They don't really do. There's no editing for the actual questions. There's just whole bunches of options about how stuff's counted, which is what's what it is. Either way, we will do a vocabulary quiz on Chapter 6. We'll do it through D2L during class, so have your laptop. It'll be under quizzes. But of course, we'll be here in class. We'll be here in lecture, so I'll walk you through the steps on that. It's going to be just like the vocabulary quizzes you're used to. I'm pretty sure I can do matching. I haven't looked at it in a couple weeks, but I'm pretty sure I can do matching stuff. So that will be fine. We'll do that. And then if I can't do matching, then we'll get over to matching by I'll give you the Word document and let you enter into the blanks. That's another option. So there's choices. I'll walk you through that on Monday when it comes to it. So that's this coming Monday. It is April. It is April Fool's Day, so be vigilant. In the words of Mad Eye Muji, constant vigilance. Don't allow yourself to be taken in by an unscrupulous comrade. I actually hate April Fool's Day because I tend to fall for people's pranks, and that irritates me. So, yeah. I've grown more cynical in recent years, so I do better about not getting caught because I'm always suspicious of people now. So, that helps. Okay, so we have Chapter 4, Chapter 5 review stuff is this weekend, so I didn't actually focus on this part, which is the due date. This is important. Deadlines are important. Both Chapter 4 and Chapter 5 assignments are due Sunday at midnight. I can tell you that a handful of students have already completed it. The average score is like a 99.6 or something, really, really good. Okay, I lied. 99.05. But, I mean, come on, that's still pretty good. Huh? Keep it up, guys. You're killing it. Great job. Okay, so then exam 2, we will do through the lockdown browser next weekend. That is not this coming weekend. That's the following one. My plan is to make it available for the entire weekend so you can take it at your convenience. However, if that's not convenient, I can potentially open it up a little earlier. I'd rather have it open for a shorter amount of time than longer if it's if it's no issue. So not that you'll be able to do the whole thing, meaning you'll have a fixed amount of time, like 75 minutes, but you can choose to start it whenever you want. And so we'll go over more details as we get closer. That's looking ahead. So we'll get back to that. You'll see what you need. Whatever you need. So we'll get back to that. Okay. So, is there going to be a practice exam? Oh, I just realized why I didn't hear you. My headset, because it's wireless, I left my other headphones upstairs again. Dang it. This is a reason why I don't want to use these headphones. Is if I don't have sound going to it, they turn themselves off, and I don't hear the notification. Which I think I could put Spotify on like really, really, really quietly, and then we wouldn't hear it, but it would still keep my headphones on. Let's find out. Is that loud enough? Okay, I think there's a whisper of sound now. I'm going to hide the Spotify preview because it's useless. Okay. I mean, unless you want to see that we're listening to the first Lord of the Rings soundtrack. Song by song. Is there going to be a practice exam? Yes, there's a practice exam. There are a couple forms of how it will be. Can't add to the Discord. You were here before? What happened? You're on my list, and you show you like you're online. Are you saying, do you mean you can't add to the voice channel? I can multitask. Okay, so, and then in terms of the lockdown browser, what is the lockdown browser? Lockdown browser is a digital proctoring tool. All right, so are you double clicking on the voice channel? That's what you got to do. I will demonstrate. Yes, I can. You're this one right here. Okay, I can definitely hear the background music now. I don't know if you guys can, but I can definitely hear the Lord of the Rings coming through. That's a really loud, a little loud spot. So I see you on the rolls. If you're trying to be in the voice call, I don't see you yet. I saw somebody just joined, but no, it's all right. What the heck? I'll leave it the Spotify plugin. This is the first Lord of the Rings soundtrack. No, the score. Excuse me. That's not a soundtrack because there's not like, it doesn't have. It's not Shrek. It doesn't have all kinds of like popular music just put in it. My wallpaper. Yes, it's a Mario wallpaper. I think the shuffle came off. I have a series of I know why. I have a series of wallpapers for multiple monitors, so it looks like one big fun thing. It's pretty cool. Okay. Good. Got you in the Discord. Excellent. Got you there. Okay, so that's announcement stuff. Let's do lecture files. While I'm pulling these up, I'm just gotta tell you. So, my girlfriend's family is not much for movie watching. Not that she doesn't like them; she just not exposed to very much. And she revealed to me that she had never seen the Lord of the Rings movies, and I was, of course, aghast. Right. So I said, obviously, we're going to have to remedy that. And we finally watched them a couple weeks ago before all the coronavirus stuff got really bad. And, man, I know how good they are, and I forget how good they are. Unfortunately, we don't have the Bluetooth extended editions, and my parents gave me the regular extended edition. So we watched the Bluetooth ones. It's still like 10 hours to watch the 3 movies. But generally, I say it's worth it for the extended edition. But we watched them like one movie per day. That's some long movies, man. I gotta be honest. Like, it's worth it, I think, but... Okay, now I'm going to put this in full screen, and then it's going to do the goofy thing where I have to, how do I do this? Oh, I forget. Hide presenter view? Yeah, that's the one. Okay, cool. Okay, folks, so quick review. So this is what we had done last time. I know it's been like 3 weeks since we've talked about these kinds of things, so hence review day. So this is all catching up today, and then we'll do a little bit new stuff. So remember that we did a couple other distributions before, a little bit easier. So I'm going to do Binomial and Poisson, and then I don't know. We'll talk about hypergeometric. This is chapter 5. I'm happy to skip hypergeometric, not have it included in assignments and stuff. I tried to take it out of this assignment and did not find a way to do that. So I'm not going to talk about hypergeometric today. it will not be on the exam. I will find a way to make that formalized. In fact, why don't I put it on the announcements? Oh, that wasn't it. Okay, I'll make this prettier tidied later. Okay. No, hypergeometric, we haven't got there yet. Did I guess right? Oh, it's this gross, ugly one. So you have, it's sampling without replacement in it's like binomial, which we're about to talk about, but sampling without replacement. That might not make a lot of sense yet, but that's okay. We'll get there. That's the simplest explanation, but it's also not the most descriptive explanation. Okay. So binomial distributions are when you have a bunch of things that are the same thing repeatedly, such as rolling a die or flipping a coin, which I happen to have with me. Excuse me. A whole bunch of dice and stuff. Okay, I have one set of dice. My other dice are upstairs. But I have a cool dice rolling tower my dad and I made. So, with something like a die, this is a fancy set of dice. With something like this, if I roll a die over and over again, then the chances of anything happening are the same each time. And when you have dice like this, oh yeah. What's fun about these dice is, if you can tell, it's metal. And it's heavy. I will attempt to make a sound with it. I dropped it about 3 inches to the ground. So these dice are really, really fair, which is why we prefer them to plastic dice, if you're a dork about fairness like I am. And they're also sharp. You can't really tell, but you could, these 4-sided dice that I have here, this is basically a caltrop. Like, you could impale somebody's foot with this. I mean, it's sharp. It would not feel good to step on. So why does this matter? Because we want repeatability. We want fairness in our dice. We want each side to be equally likely. And so these are high-quality dice. This set of dice was $35, which is really expensive for dice. You can buy a box of plastic dice for like a couple dollars. Yeah, so this is what it costs for quality. So I only have 2 sets of these. I have 2 metal dice. I got one that's really pretty, and then these are actually, I think these are the ones that are more fair, even though I like the ones I like the look of the other ones better. And then I have a whole bunch of plastic dice for when I just want bulk stuff. As we talked about on Monday, I play Dungeons and Dragons for fun. Okay, so the point of this is all about item number 3 right here. The probability of success does not change from trial to trial. And number 1, similar idea, we have to have identical trials. So I'm rolling a die, and my outcome is the same each time. Now we have an idea of success and failure. So we're currently experiencing the loop that I talked about. We're currently experiencing the loop that I talked about. Okay, I'm going to mute you. If you either mute yourself or get some headphones or whatever put in, let me know. Although you had headphones on yesterday. Is it possible that I'm getting a feedback loop? Let me check. It shouldn't be. Yeah. Getting my voice from my USB audio. Okay, so I was saying, yes, it's very important that your trials be repeatable and be the same from time to time. And if this is the case, we have the idea of success and failure. I need to roll a certain number in order for something to be considered a success. So in Dungeons and Dragons, for example, using the dice for an example, we use a 20-sided die for a lot of things because each one has 5% chance of occurring. So this is what a 20-sided die looks like. 20-sided die. And so then, based on various factors, you have a certain threshold number you need to reach. And if you reach the threshold, you pass. If you fail the threshold, you fail. So we have this idea of repeated events and the same event, same trial over and over again with the idea of success and failures. Now, it could also be, what is the probability that I go to a grocery store and it actually has toilet paper, right? It can be anything like this. I like to stock up on toilet paper, and I just buy things in bulk in general. Like I went to Costco and bought a huge thing of cereal. It's just kind of my personality. I don't like to go to the store if I don't have to, so I buy lots of things in large quantities. My girlfriend, unfortunately, doesn't have much storage space in her apartment, so she buys like little boxes of everything. And then everyone buys out toilet paper, and now she's driving around town trying to find toilet paper. So many of you may have experienced this. It's really frustrating. And in a sense, it's actually a binomial distribution because you either find toilet paper or you don't. And assuming that this, relatively same number of people are shopping at each store, and each store has a similar supply chain process, then the chances of each one having it should be about the same. We don't know what the probability is necessarily, and right now it doesn't look very good, but it's a repeated event. So the question is, how many successes occur in a number of trials? So in the case of trying to find toilet paper, we just need one success. But sometimes we're interested in more than that. So we might look for an X number. So there's N total trials and X individuals. So we have N here and X here. So we have the total number of trials, factorial, which if you remember, factorial means N times N minus 1 times N minus 2, and so on. So we have N factorial divided by the quantity X factorial times N minus X factorial. And all of this times P, the probability of success, raised to the number of successes, times 1 minus P, quantity, raised to the quantity N minus X. Reading these formulas sucks, which is why mathematicians have come up with notation, ways of making this easier, because it's just really hard to read or to write it out in long form. Okay, so what are these two components? Let's just do one. So the first half is a combination. If you remember the combination formula, this is the number of experimental outcomes providing exactly X successes in trials. And what I mean by that is, how many ways can we get X successes out of N trials? So like if it's one success in 3 trials, is that success, failure, failure, fail, success, fail, 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 success? There's 3 ways to do it. So what combination, like how many sequences can we have this happen? And then part 2 is the probability of a particular sequence of trial outcomes occurring. So success, fail, fail means probability of success times probability of fail times probability of fail. But because they're all multiplication, it's commutative. It doesn't matter the order that you do them in. So we can clump all of the probability of successes together, and we can clump all the probability of failures together. And so that gives us this nice handy formula. Of course, you don't have to know this in terms of what these 2 chunks represent. It's nice and helps you maybe build some intuition about why we're doing what we're doing. But I'll give you the formula sheet as usual, so you don't have to memorize it. You just have to know how to plug things in. So this is the example problem we did last time. Consider Evans Electronics, who's concerned about a low retention rate for its employees. In recent years, management has seen a turnover. I had a water bottle down here. I lost it. In recent years, management has seen a turnover of 10% of the hourly employees annually, meaning that 10% of your employees leave each year. That's not counting the ones that you fire. Thus, for any hourly employee chosen at random, management estimates a probability of 0.1 that the person will not be with the company next year. Choosing 3 hourly employees at random. Actually, it might include firing. I've always assumed that it didn't, but it might. I'll have to look later. I don't know. It doesn't matter for the sake of the illustration. Thus, for any hourly employee chosen at random, management estimates a probability of 10% that the person will not be with the company next year. Choosing 3 hourly employees at random, what is the probability that exactly one, notice it doesn't say the word exactly right here, but it's there, exactly one of them will leave the company this year. I just got a notification on my phone that doesn't make any sense. Oh well, I'll figure out what that means later. Oh, I know what it means. Cool. I can sleep tonight. Good. That drives me crazy when I leave a notification for myself and I don't know what it means. I stress out. Okay. The probability of the first employee leaving and the second and third employee staying. Denoted success, failure, failure. Remember I told you, I gave you this example a moment ago. Aha. There are 3 things, 3 employees, and one of them is a success, which in this case is a person leaving. It's not trying to say that like we want the person to leave or we don't want people to stay. That isn't the point at all. It's just that we're going to call something a success and something a failure. And so we've decided to call people leaving us a success. Doesn't matter. There's no emotional connection where success is good. Doesn't matter. So we're concerned with 3 employees, one of whom leaves. So either the first person leaves, which would be probability of leaving, probability of not leaving, all multiplied, which is 0.1 times 0.9 times 0.9, or 0.1 times 0.9 squared, 0.081. Similarly, there are 2 other ways this can happen. Fail, success, fail, and fail, fail, success. All 3 of them have the same probabilities here. P times 1 minus P times 1 minus P. 1 minus P times 1 minus P. 1 minus P, 1 minus P times P. So all of them, all 3 of these options, have a 0.1 and 2 0.9s. It's either here, here, or here, which follows the same pattern as where the S is. So all 3 of them have the same value. Each possibility has the same probability, 0.081 in this case. And how many of them are there? 3. So 0.081 times 3 gives us the 0.243. Now in this example, we're actually adding them. But the reason I describe it the way that I do, saying multiplying, is because we're about to see that when you use the binomial formula, you'll get the same result that we just computed here. And in fact, we'll compute the same values. So what we're going to show is that the binomial formula will give you 3 times 0.1 to the 1 times 0.9 squared. Let that sink in. The formula will give us 3 times this squared. So we will get with the formula the same thing we just illustrated would happen in real life. So hopefully this will sink in. It'll kind of start to make sense. It's where the formula comes from. Where the formula came from, I'm from the South. Sometimes it just comes right out. No, I just can't speak English in any accent. Okay, so if we use our function, we have our formula, and we plug in the values. What is n? 3. Okay, 3 factorial. What's x? 1 factorial. 3 minus 1 factorial. Okay, so let's just focus on this part. 3 factorial. I'm going to bring my iPad down here tomorrow. 3 factorial, so I can write with my actual hands. Okay, 3 factorial is what? 3 times 2 times 1. divided by 1 factorial, which is 1, times 3 minus 1, 2 factorial, which 2 factorial is just 2 times 1. So these go away, and we get left with 3 over 1 equals 3. So that is how we get, 1 factorial times, do it this way, 3 minus 1 factorial. Okay, so this is how we get the 3, if you recall. The 3, yeah, this 3. This, the 3. That's how we get it. This is where we get it in the formula. Through this portion. This gives us that 3. And then we have the 0.1. So we take our probability of success, 0.1, raised to the power of the number of successes, 1, times 1 minus p, 1 minus 0.01, or 0.9, raised to the 3 minus 1 power, which is 2. That gives us our 3 times 0.1 times 9.9 squared, or 0.9 squared, or 0.81, which multiplies out to 0.243. So we get the same value either way. Oh, I am struggling today. Sorry, folks. Okay. Back to my laser pointer, I guess. Oh, yeah, that's handy. I should do this more often. Okay. Now, we have our tree diagrams that we kind of hate. Here are the choices, right? Here are all the possible combinations of things that can happen. So the first person, now this is not sequential, meaning it's not like this guy decides to stay or leave, that guy decides to stay or leave, the third guy decides to stay or leave. It's just all happening at the same time. So the first person could stay, the first person could leave. Regardless of what happens, the second person stays or leaves, and regardless of what happens here, the third person stays or leaves. So X here is the number of successes, meaning the number of people who have left out of the 3. So here, obviously, we have a leave, leave, leave. That's 3 have left. So X is 3. Leave, leave, stay. 2 leaves. Leave, stay, leave. 2 leaves. Leave, stay, stay is 1 leave. Aha! That's one of the ones we're interested in. Leave, stay, stay. Stay, leave, leave. That's 2. Stay, leave, stay. Aha! Another one. So there's the 1 there. Another one. My meme reference for the day. 9.9.9.1. So again, we're multiplying the probabilities associated with each of the leaves for the ones that follow down the branches. So stay, stay, leave. That's one of the ones we want. 0.9 times 0.9 times 0.1. So general comments of tree diagram you probably forgot is you associate probabilities with each of the individual events, like first worker leaving. And then for any of the combinations that meet your criteria, leave, leave, stay, for example. Leave, stay, stay. Not leave, leave, stay. Leave, stay, stay. Then you multiply all of those probabilities down the line of the tree, down the branch of the tree, and that gives you the probability for a combination of events, a sequence of events. So that's very good to keep in mind. This is a brute force way to solve these kinds of problems, and it definitely has disadvantages, but it also is visual and it's very tangible. So for small problems, tree diagrams can be really useful and really help you illustrate what's going on in the problem. But obviously for big problems, they're just intangible. It's just, intractable. They're just way too big very quickly, either because there's a large number of options or a large number of steps in the process. Either way, it becomes undoable. But for small problems, it works out pretty well. By the way, I forgot to mention this earlier, but I am recording the lecture, so I will be putting up the VOD onto D2L after the class. Based on previous experience, the videos are relatively high quality in terms of file size. So if you have any issues, I can record them at a higher a higher bit rate, but it will take longer to upload and be harder on your computer to download and things like that. As it stands, the raw file is about my first one was 1.3 gigabytes and took like an hour to upload, so it already takes kind of a while. And to go up any higher in the quality would take even longer. But if you can't read the slides, then we need to do that. But at least it looks fine to me. We'll see. Okay. So binomial probabilities and cumulative probabilities. So we just talked about how to compute an individual value, but sometimes we want to know a cumulative value. As someone asked earlier, is that the one that's at least or one? Virgil, that's the one who asked. Is that the one that says at least one or more? That's where this comes in. So cumulative probabilities can be computed from tables in the textbooks. Remember, I told you in the ebook we have tables at the end, so you might need them for some homework questions. Now, of course, with a full calculator or especially a modern statistical software package, you won't need them. However, we're not using those in my class. You will not be allowed to use them on the exam. You need to use the table in the class. When you move on beyond this class, you are encouraged to use those software packages. I will personally teach you how to use those packages, but for now, we need you to learn the processes and the theory of how to solve these problems by hand so that you understand what your computers are doing. It's very important. Okay, so what a table might look like is this. So you say, okay, I've got a total of three people. Whoa, computer. Okay, there we go. Three employees, and I want to know the chances that one of them leaves. Okay, well, that gives us this row in the table. So 3 employees gives us this table. One person leaving, one success, gives us this row of the table, and then we look at what the probability of success is. In our case, 0.1. So we're in this table because n equals 3. We're on this row because x equals 1. And then we choose this column because p equals 0.1. And that gives us a total probability of 0.2430. So this is a third way of computing or finding the probability. Now, this is not a cumulative probability, by the way. This is just a probability. However, the cumulative binomial probability tables work in exactly the same way. So I'm giving you this example because it illustrates how the tables work and compares it to something we've seen before. But then the cumulative versions will give you a cumulative answer. Okay, so some fun things for binomial. The expected value of the binomial distribution is n times p, the number of trials times the probability of a success. The variance is the expected value times 1 minus p. So it's n times p times 1 minus p. So if you already computed average, you just take the average and multiply it by 1 minus p. So in the case of our previous example, 3 trials with a 10% chance of success. That means 3 times 0.1 is, of course, 0.3. And then, so we have 0.3 times 1 minus p, which is 0.9. 0.3 times 0.9 is the same thing as 9 times 3, 27. But then you move the decimal places to the left, and it's 0.27. And as always, standard deviation is the square root of the variance. So it's whatever the square root of 0.27 is. I don't know off the top of my head, but it's somewhere between 5 and 6. It's like 5.1, 5.2 maybe. So 5.2, got it right. Okay. So those are the numbers that I just told you how to calculate, right? I said the same things out loud. They're the formulas. That's how it goes. They're formulas. You don't have to memorize why they work. You don't have to memorize them at all. You just need to know how to plug stuff in. Where did it get that? So fun fact, a little interjection. My parents are, our home is at least partially protected by the federal government because we have osprey nesting on our roof. We have our chimney particularly. There are osprey nesting, and osprey are an endangered species. They're a very large bird, and they build a nest on the chimney. Because they're a protected species, we can't remove them, despite the fact that they drop partially eaten fish on our porch and lovely things like that. But so one of the birds just flew by with a really big piece of like sticks and straw and stuff, and it looked like a completed nest from another bird. So I got distracted. It's a very large bird flying by the window. Okay, before I move on, binomial distribution. Any questions? Are we all happy with binomial? You laughing at my osprey? They're a majestic creature, okay? Look at this. Look at this little guy. I say little guy. They're pretty big. It's a large raptor. Well, I guess this is specifically a western osprey. Look at this guy. Look at him. He's beautiful. Yeah. You wouldn't understand. Unbelievable. The attitude of some people. So, binomial. I know, right? Sharp. Raptor. Man, that's a dangerous bird. Oh, yeah. So, hopefully you'll forgive me when you see... Oh, yeah, there he is right there. No, come back. Oh, it's coming back. Yes. Well. Oh, well. No, they're recharging the bird's batteries. Don't you know? That's what the coronavirus is all about. It's actually a hoax. The government's replacing the batteries in the birds. That's why I'm here, actually. I've been lying to you. I'm actually recharging the birds' batteries here. I'm a government agent. So, any questions on binomial? I have to actually have it selected, don't I? There we go. Now, I think I told you, Poisson is my favorite distribution because it is the general distribution for when you don't know anything. It's like we don't know, so we'll just pick the most generic thing. Which it is. Poisson distributions are useful for a lot of different circumstances, meaning that they do model very well a lot of true randomness very well. So it's a very popular distribution and used frequently in applications and research and other places as well. So very, very popular, very common distribution, which is why I want to cover it. Hypergeometric, the one that we're taking out, which is after this in the lecture slides, is very specific. It's only used in very particular circumstances. So it's complex. It's harder to use and less useful. So I'm happy just to cut it out for the sake of time. Okay, so Poisson, my boy, Poisson. A Poisson distributed random variable is often useful in estimating the number of occurrences over a specified interval of time or space. So like in the next 10 minutes, how many people are going to arrive looking for toilet paper at a grocery store? I don't know, something like that. So this is a discrete random variable, and it may assume an infinite sequence of values. There may be some limitation on it, and in which case we have to make a little bit of adjustments to the distribution. But you can make shortened lists. But for a regular Poisson, we assume specifically we are requiring, we have to have an infinite series of values. Infinite. Now, what usually happens is that very, very quickly, the probabilities of, let's say, x equals 10 are really small, like 0.001 or something, a tenth of a percent. And so long before you run into any practical restrictions, the probabilities become so small that it doesn't really matter. So that ends up being not a very big hurdle. So some other examples. How about the number of knot holes in 14 linear feet of pine board? When you're cutting, trying to saw through a knot hole is usually ill-advised, doesn't go well. So you're going to have to adjust where you cut based on your pine board. So the number of knot holes is a big deal. Also, some people consider them unsightly. In some circumstances, knot holes are considered beautiful in character, but other times they're not. So maybe it's a good thing, maybe it's a bad thing, but that's a Poisson variable. Or how about the number of vehicles arriving in a toll booth in 1 hour? That's Poisson. So you have a fixed interval and then a discrete number of arrivals. So Poisson is usually given in the context of arrival. So something happening over time. Usually it's arrivals, but it can be called other things as well. Or how about the number of phone calls that are going to be arriving? This is another one right now. So this is a discrete example, but right now there's a lot of utilities and things that are being taxed more than usual, meaning by they're overwhelmed, they're overloaded. So that's what I mean by taxed, because everyone's at home. So people's internet is under high demand. And then particular servers, so like Netflix, Google, I've seen lagging. I've logged onto a couple other servers that are games that I've played where they've given me a notification like, hey, just so you know, there's a lot of lag going on right now. So because the servers are just overwhelmed by everything. So it's very important to know for Bell Labs how many phone calls are going to come in. So that is a number of users over a given amount of time tells you what capacity you need to be able to handle in terms of calls per hour. So these are really, really, really important questions to answer. There are only two properties that we have to worry about for a Poisson distribution. Number one, the probability of an occurrence is the same for any two intervals of equal length. So you look at 1 to 2 o'clock in the afternoon versus 2 to 3 versus 3 to 4, whatever. It doesn't matter. All of the occurrences are equally likely, or the number of occurrences, the probability of a given number of occurrences is the same no matter what. Either way, super, super simple. It's got to be the same, which is just like the binomial. It has to be consistent the whole way. It has to be the same each time. Similar also to the binomial, occurrence and non-occurrence, meaning arrival or a no-show or whatever you want to call it, in any interval is independent of the occurrence or non-occurrence in any other interval. So it's stationary and independent, two very important properties. Okay. Remind me, by the way, there's a really cool feature in Twitch where you can do something called clipping, which allows you to rewind stuff. Even though we're watching, this is a live stream, you can rewatch things. If I go too fast on something, I need to show you guys how to do that. It's really useful. And, when I tell a witty joke, you can save it for later, and you can send it to your friends and encourage them to come to NEIU. Best education. Best value education. Or just make fun of me. Either one. I don't really care. Okay, here's the formula. This formula, if you ignore the letter E, it's very easy. It's a bit of multiplication, a bit of division, and some exponents. Okay, and a factorial. Okay, so there's several steps. It's a very compact formula, given how much is in there. So that's a little bit of a downside, I suppose. But that's really it. So you have mu, which is the mean number of occurrences. So that's this guy right here. Mean number of occurrences raised to the x, which is our value of interest, the number of occurrences in our given interval. So, in 3 minutes, what's my probability of 2 people arriving? Okay, so there's your 2. And then E, now this is Euler's constant. 2.718828, whatever. Most calculators have this value built in. There's an E button. If you don't know where it is, I can help you. Yes. So this is like I just said. It's called Euler's constant. It's literally that. It is constant. It will not change. It is always 2.71828. I will not bother trying to explain why. Just know that it's the same every time, and you can count on that. Hi, kitty. My cat's perched up. He's keeping watch. Good boy. He's the man of the house. The youngest man of the house, but nonetheless. Anyway, so there's an E button on your calculator, and if you want to use that, or otherwise you can just type into your calculator 2.71828 raised to the negative mu, which whatever the mean number is. I've not noticed. He's generally intrigued with everything that happens outside. So there are other birds and stuff. You know, this is rural. It's from the middle of nowhere. So I shouldn't say that. We were in the middle of nowhere. There's like a tequila place. What do you call it? Tequila Azul, I think is the name of the restaurant. That's why I call it Tequila Place. It's a Mexican restaurant, but they call themselves Tequila Azul. That's like 15 minutes away. And then now we have another Mexican restaurant close by, like a nail salon. Yeah. It's almost suburban. Anyway, so formula. Oh yeah, definitely. My mom is so funny. She likes a good margarita. Like one. But she really likes it. She's really enthusiastic about it. Came home a couple days ago. And she'd had 2 margaritas. She was a little giggly. It was really funny. She does not hold her alcohol. Okay, so mu to the x times e to the negative mu, all divided by x factorial. And again, x factorial, x times x minus 1 times x minus 2, etc. So it's a formula. I'll give it to you on the formula sheet. Plug and chug. Call it a day. Simple as that. Okay, so I talked about this already. There's no stated upper limit for the number of occurrences, so the probability function is valid for any number of positive values or non-negative. 0 is not positive, but it is eligible. So think about it this way, like, what are the chances that I have -1 phone call? What? You can't have a negative phone call, right? You can have a phone call about that doesn't go well, but you can't have a phone call like sucked out of your pocket. You can't lose a phone call. That doesn't make any sense. So Poisson probabilities start with x equals 0 and then go up forever. But practically speaking, the x values will largely turn into, or the probabilities of an x value will turn into something where the probability is negligible, that it just kind of doesn't matter. So often that can happen quite quickly, but it depends. Okay, so suppose that patients arrive at the emergency room of Mercy Hospital at the average rate of 6 per hour on weekend evenings. What is the probability of 4 arrivals in 30 minutes on a weekend evening? Okay, so you might have said, that was kind of weird. Why did I say weekend evening twice? Well, it's very important to emphasize the fact that we are comparing apples to apples. We need to make sure that we're not comparing weekend evenings to weekend evenings. We're not comparing a global pandemic to a regular weekend evening. We need to make sure we're comparing 2 things that are equivalent. So, if the average is 6 per hour, notice something else. 6 per hour compared to 4 in half an hour. Is that above average, more people than usual, or is it fewer people than usual? Let me know. What do you think? Put it in the chat. More or less? There's a poll system. I need to get it set up. That'd be kind of fun. Okay. 2 votes for more, 1 vote for fewer. What do you guys think? Come on. There's 30 people in the chat that haven't responded. Come on. Get some fingers going. Tickle your keyboard. You can do it. There's a lot of people saying more, and I'm pretty sure 4 is less than 6. So, it's a trick question. Yes. Thank you, everyone, for chatting in. So, the 6 per hour is 3 per 30 minutes twice, right? It's 3 for the first 30 minutes and then 3 for the second 30 minutes. So, it is fewer people per hour than 4 in 30 minutes because that's 8 per hour, right? 4 plus 4. So it's what is the probability of exceeding going up to 8 arrivals per hour? So in a problem like this, you have 2 options. Number 1, you can scale the average down from 6 per hour to 3 in 30 minutes. Or you can answer the question, what is the probability of 8 arrivals in an hour? It doesn't matter. You'll get the same answer either way. What matters is that you compare your x and your mu in equal rates. So people per hour or people per half hour. Either way, it works just fine. So in this example, we have used the divide by 2 for half hours option. So we have 3 people per half hour is our average, raised to the 4th power because x equals 4. We said 4 people for arrivals right here. So 4 arrivals with an average of 3. So we plug in 3 to the 4th times e to the negative 3rd, which is the same number as here. So just kind of some little things that might be useful. I don't know that it really is, but this number right here comes up here with a negative sign. And then this number comes down here with the factorial. So for some reason, that helps me. I'm not sure that it really matters, but for some reason, it seems like it makes sense in my head. So you can decide if you think that's useful for you or not. I don't know. For some reason, it seems like it helps me. But yeah, so you just plug those numbers in. Okay, that ink is really annoying. All right, so, come back. You plug the numbers into your calculator, and it spits out 0.1680, and you call it a day. Write it down, circle your answer, you're done. That's all there is to it. Plug it in your calculator. So again, the whole challenge here is to know what to plug in your calculator. Know what goes in the formula, type it in. That's the hard part. And then maybe finding the e and factorial keys. But, you know. Okay, so just for fun, here are the number of probabilities, or the probabilities for given numbers of arrivals in 30-minute intervals. So you can see that the average was what? 6 per hour, right? So the average 3.5 hour is the most common value. Now, because the so things that are higher are less likely, things that are lower are less likely, but because 3 per hour is so small to begin with, there's very little room for lower alternatives. So all of this probability is kind of squished together. It doesn't spread out very well. So over here, you see there's lots of spread for the probability, right? It's distributed not evenly, but distributed amongst a bunch of different values. But over here, it's all squished. So you end up with having slightly fewer arrivals is not uncommon at all. In fact, you have the same probability between 2 and 3. But then you see it drops off very quickly. Excuse me. This is the 5% mark right here. 5% of having 6 in 30 minutes. And that's just at 6. We've only doubled it. As you go up, the probability gets small very quickly. I don't know what this number is, but it's not very big. And this is just 10. So I told you before, this is an infinite sequence, but it kind of doesn't matter. So, meaning the fact that it's infinite practically doesn't make much of a difference because, sure, yeah, it's going to keep going, but the values are so close to 0 that, it might as well not be there. Okay, mean and variance. So fun fact, the mean and variance are equal. And I had to give you the mean for this distribution to make any sense to begin with. So the formula for mean is nothing. I have to give it to you. It's how you define the distribution. So There's no formula for mean. I just gave it to you. And the mean and the variance are equal. So if I give you the mean, I've also given you the variance. If you are aware of this, you don't have to define that yourself. Now, of course, how do you get the standard deviation? Take the square root of the variance, or in this case, square root of the mean. Yes, great question. Is this only for Poisson? Yes, this is specifically for Poisson. So that's one of the things about it that's so cool, is that the mean and the variance are equal, which has actual practical implications, but it's kind of hard to explain. So there's an example. Okay, so there is hypergeometric, and there's some stuff on here, which I'll kind of talk about it for like a second, just because it's in the homework, but I'm not going to put this on the exams. I don't want you to worry about it. It's not that important. The important thing is that hypergeometric is just like the binomial, except that without replacement. So like if you, it's sort of like sampling, but then you're like taking people out. So your probabilities are changing over time. So you have 3 combinations, which means that putting it in a calculator is an absolute nightmare. It's really, really easy to make a mistake, which means that it's if a student actually manages to type in all the numbers and do all the math without making a mistake, it's impressive, more than just like expect it. It's a lot of math. It's a huge pain. So that's another reason why I don't want to like really require you guys to do it. It sucks. For the sake of the homework, there are websites that'll do the calculation for you. You can type in like hypergeometric calculator, and you can just do it like that. I don't care. It's just a giant pain in the butt, because of the computation is such a nightmare. So just so you can kind of see what it looks like. 2 factorial divided by 2 factorial times 0 factorial times 2 factorial divided by 0 factorial times 2 factorial, all divided by 4 factorial to 2 factorial. 2. So if these are big numbers like 10, 20, 30, 50, these numbers become gargantuan. You know, like 10 billion divided by 700,000 times 20 million, and it's just like, You're literally the memory will overflow in your calculator. If you have a cheap calculator, it can't even do the math. These numbers suck so bad. It's just awful. So, there's a problem for you in the homework. If you want to use a calculator online, I don't care, whatever. And look, the variance formula will literally give you nightmares. It's not that bad, but like, why? It just, come on. Ew. It's just too many steps, man. N times R over N times 1 minus R over N times N minus N divided by N minus S. Ugh, gross. Okay, so now kind of interesting thing here is that as the population size gets large, then you end up with these formulas, which these might look familiar. So as your population size gets larger, hypergeometric ends up being equivalent to binomial, because the idea of without replacement doesn't matter, because the population is so large that it's not changing over time. So what do you know? You get to stick with binomial. So that's kind of handy. So when the population size is large, hypergeometric can be ignored entirely and approximated by binomial distribution with n trials and a probability of success of p equals r over n. So not only am I telling you to ignore hypergeometric, but oftentimes you can anyway. So yeah, don't worry about this. Again, there is a hypergeometric problem in the homework, but if you use a formula on the calculator online, I won't be upset. So okay, so that is it for Chapter 5. That's everything. So that'll be it for today. We're done a few minutes early. I'll get this video uploaded to the D2L page in a while. It takes a while to upload. And don't forget you got your homework. I will be hanging around on Discord today and tomorrow. So if you have any questions about getting into MindTap or anything like that, shoot me a message. I'm not. I find that the personal messages, the DMs, direct messages, are a little obscure. I don't tend to notice them. I would rather you ping me in the Discord. You can send me a DM if you don't want to put your question publicly. I'd prefer that you do that, but whatever. It's also just faster. Happy April Fools, absolutely. And here's my parting message. Look at this majestic beast. Oh. Just keeping me company over there. So that'll do it. SpongeBob's favorite holiday. Is it? I actually don't remember that. Will I be available for questions? Absolutely. Yes, I will. I will be in the Discord. But I'll go ahead and kill the stream so I can kill the recording and stuff. Oh, how can we access tutors? Thank you. Did I forget to put that on the usher slides? I know I put it on the other one, but I must have forgotten on this one. I'm glad that you asked. There is a shared... Let me go ahead and get this on here. Oops. Where is it? There is a shared... shared email called quanttutor@neiu.edu. Let me double check if that's the right email. Yeah. See, I put it in the other one for $3.79. Okay. quanttutor@neiu.edu. Now, the hours have been changing. I think you saw an email. You've probably seen emails about it. I know I saw one about accounting and finance earlier today. I don't actually remember what everyone's hours are right now, but they are doing tutoring through, I think, Google Hangouts or maybe Zoom or something. At any time, you can email them at this shared email, and one of them will reply to you quickly. And of course, you can always access me. I'm here to help. So, if you have any questions, you can try the tutors, or you can put a message in the Discord, and you can see if anyone else wants to answer it. So, teaching others is the best way to learn, they say. So, if you want to just kind of ask a question in the group. When will the exam 2 review be up? Not this week, because the exam isn't this week, but probably early next week, I would say, because we're going to do, normally I try and have it up 5 days or so in advance with the exam on Monday. So I would have it up Friday to Wednesday beforehand, but doing the exam on the weekend, I'll probably get it up around, maybe the end of this weekend, maybe the beginning of early next week. I need to check into that. I think you may, depending on what we have access to. So there are different types of, different grades of the software, depending on what we've paid for. So I need to see what we have access to at NEIU. So I know there is a... let's just see. If I click new quiz, no. Yeah. Let's see. I did this the other day. How did I do this? Oh, there it is. Lockdown browser. Okay. So, continue. Do we have this is the one, right? Okay, so this is the one that you need the vocab, you need the webcam for. This is what I wanted to use. I'm pretty sure this is it, so I'll double check, but you will need a camera. You can get them for a few dollars. I don't know, like if you can order one from Amazon or something. Let's see. So this is like a fancy one. This is $40. You don't need to pay that. These are all so expensive. What the heck? Okay. Well, I know mine wasn't this expensive. Don't buy it at Amazon, I guess. Maybe they've gouged the prices because everyone's working from home. That would be really lame. $25? Even that's more expensive than I was expecting. $20? That's a cover. Good Lord. Sold out. $1,500. That's absurd. Really? I guess I shouldn't be that surprised. Okay. I'll have to think about that. It may be that you can use your phone or something like that. Yeah, I can believe that. Yeah, so if you have a laptop or a tablet, both of those should be fine. You're going to want to do homework. Like, you're going to want a piece of paper to do workout problems potentially, and then put the answer into the computer. Oh, yes, sorry. Someone else asked me and I forgot that. So you are allowed a cheat sheet, 1 page, 8.5 by 11, piece of paper, cheat sheet. There's no chapter 5 vocabulary quiz. We're not going to mess with it. But there is a chapter 6 quiz on Monday. Let me make sure. I don't have it bookmarked on here. I need to look at that. It may be that they're hard to get at an affordable price, in which case, no, I'm not going to make you go out there and it's not fair for me to go out and ask you to pay $100 or something. Because everyone's trying to work remotely, so you may be just not able to get them right now. For heaven's sakes, you can barely buy toilet paper. I mean, there's only so much that we can do. So, yeah. See ya, Annie. Time's up. So, capitalism at its finest. Yep. Absolutely. So I'll get into this and make sure, see what actually we can work with. So, yes, cheat sheet, vocab quiz 6. I wanted to make sure. I think I may be confusing something with something else. Let me quickly look at. No, that wasn't it. This one. I can't. I might be mixing up my 2 classes. Let me see. Yeah, chapter 6 only has 6 words, so hopefully that's that's manageable. So, yeah, we're not gonna mess with chapter 5 because we would have had to do it today, or we got to do it like on Monday, which doesn't make any sense. So, no, we'll just do chapter 6 on Monday. Those 6 words. Make sure you know them, and we'll all be good for the vocab quiz. So, if you have any other questions, I'm going to end the stream and I'll be in Discord. So, if you got to go to work or whatever, everyone good luck. Stay safe out there. Wash your hands, which hopefully you do that anyway. But, yeah, stay safe out there. See ya.